All right. This is very annoying. All right, so everybody understands that it's the internet, right? It's just quite a few networks all connected together. The networks of networks, right? And some of you might know a little bit about the history and how perhaps it was a Defense Department projects for quite a while, trying to plan on how we would survive World War III. It says what kind of network could survive intensive bombing for quite a while and still be redundant enough to for us to be able to maintain communication. It was never intended for commercial purposes, for entertainment purposes. Nobody ever thought of what the internet is today, and still I think classified as an entertainment network. And it's not. I guess it should be a very important infrastructure, right? That if we get attacked, the internet gets attacked, it's be very, very bad for our economy. Anyway, we have lots and lots of networks within networks, right? Have little networks inside, local area networks and wide area networks. And each one of these is lots and lots of little computers that are just able to connect to one another if they know the address or IP address of each one of them on the network. As long as you know the IP address of a machine, presumably you could connect these two machines together. And there's quite a few protocols or mechanisms that formal ways that data zeros and ones are used to transfer the data. We call those protocols. FTP, UDP, SMTP. There's quite a few of them out there, right? On how they format the data, and usually they're targeted for different purposes. Okay, and typically some of these all these machines are equal in the network, but some of them are given special roles, right? For instance, you might have a particular machine that is dedicated to storing lots and lots of files on a network, right? And everybody else, instead of having a copy of these files, they dedicate one particular machine to be able to serve these files to the other machines on the network. So oftentimes we call the file server, right? So some machine that is dedicated for that particular role, right? And some of them might be hosting some big data that again, all the other machines are not necessarily want to have this machine replicated everywhere. Again, they go back to that machine for data from that server, from that machine. So it's just a machine like any other, but it has the role of serving that information or that resource to everybody else. Yes. So the only difference is that a particular machine that serves is just running a specific piece of software that allows it to be a server, right? Of listening in for requests on a particular port. And on that port, there is a soft piece of software listening on that port, ready to receive commands to then retrieve that information. So that became a very common architecture across the internet of having these the pieces of software that asked for the information. We refer to them as clients, and the pieces of software that were serving the data, the information, or the resource, we call them servers. Okay, and this became a very popular way of architecting applications, right, and on a distributed network, and we refer to it, as the client-server architecture. Okay, and it's still very popular today, right? It's funny how history kind of repeats itself a little bit. We used to have this dumb terminals, right, with these amber or greenish dumb terminals in front of us, and then we have this huge mainframe somewhere, right? And everybody went to the mainframe to fetch data or to run programs. We kind of went away from that when we started having personal computers, PCs, which fairly powerful little machines that would sit on our desktops, much more powerful than our dumb terminals. Yes, so the mainframes perhaps lost some of their importance. Now software was released for individual PCs that would run. But we're kind of going backwards now, right? Now there's a lot of the pieces of software that we've come to love are now moving their way. They're going back to servers, right? All the main pieces of software that we've been using for the last couple of decades are going back to being hosted on the web. Oh, this is falling asleep. Wait, I need to plug this in. All right, there we go. Okay, so yeah, client server is still the underlying architecture that we are still going to be using for quite a while. It's the the underlying framework that we're going to be building things. Okay. All right. So come the World Wide Web in the early '90s, right? Somebody said, "Ooh, you have all this data all across and dispersed everywhere." And it was very cumbersome to use the internet. If you wanted to retrieve something and view it, you had to maybe do FTP. Download that particular document onto your local machine. Use a particular viewer to open up and render that content. It worked, right? But it was not seamless, right? So somebody had the idea, says, well, what if we marry some of these mechanisms together, right? And what if we standardize a little bit some of the rendering of this information? So what if instead of having all these disparate viewers, right, and these disparate protocols, what if we agree on a protocol that the information that you're going to provide here follows a particular formatting standard that I can merge together the mechanisms by which I fetch this, and then I render it also, okay? And that's where the first browser was born, right? That just give it a name of a machine, of a particular document, it would download it, cache it, and render it right there and then, right? So Tim Berners-Lee, invented, unbeknownst to him, right? This very easy mechanism by which really lower the bar by which documents could refer to one another, by which they could be fetched, stored, shared amongst a wide area network. It took off. It just exploded exponentially. How many people were using it across the various universities and research institutions? Eventually, it was opened up for commercial use, and the rest is history. So now that so many people were using it, they were immediately identifying is a lot of restrictions, or a lot of just hitting the boundaries of what you could do with just HTML, right? HTML, the language of which we write content today, right? So they were thinking about, well, what else could you do? So, for instance, one of the things that they were thinking is that, or they realized is, oh, wait a minute, this HTML is static, right? It's always the same HTML, no matter from where you come to. It's the same content, always, right? It was meant to be static. So how could we make it dynamic, right? Well, one of the things is that I would like to have maybe a personal interaction with that content, right? If I hit it from Northeast, and this is perhaps I would like to remember me, right? And give me my weather. Right, but if somebody hits it from Florida, they might get a better weather, right? So depending on who accesses it, right, depending on zip code, depending on certain inputs, this HTML might be different content, right? So several technologies came around to allow you to do that, right? We wanted to create a mechanism by which this HTML would not be a static text, would not be just plain old ASCII, okay? So lots and lots of mechanisms came along and says, okay, what if the server could intercept a request, yes, and that request would execute something on the server, implemented on C, on C, language C, yes, run it on the server, and then that server, that executable, could then just spit out dynamic HTML. Just this would be a calculated text string as opposed to a hard-coded text string, yes. And that's where server-side technology, server-side dynamic content was born, right? Obviously, this was iterated over several years. Many industry leaders jumped on this idea, and you have tons and tons of frameworks today that support this mechanism, right? So PHP, Python, JSPs, ASPs, all these different frameworks have been around for decades, right? With this idea of something that executes on the server, and that execution then generates a dynamic piece of string that, when it gets to the browser, doesn't distinguish this from anything either static or not. As long as the browser is concerned, this content was always there, right? But now the HTML is dynamically calculated. Make sense? Okay, that's not what we're going to do in this class. Right? We're not going to do server-side technology. Well, we are. The last week we are going to do a little bit of it, right? Because that still has one important aspect, and so we will talk about that a little bit towards the end. Nevertheless, it's a technology that has become very mature. Right? ASP has been around for quite a while. PHP, Python, JSP. These are technologies that have matured over a couple of decades, and we are copying a lot of that. Those things that they invented. A lot of those things are making their way towards client-side programming. Okay, so if you've been doing server-side development, a lot of those same ideas are being reapplied on client-side programming. So let's look at what we mean by client-side programming. Okay. So anyway, this technology of server-side, JSPs and PHP and ASPs and whatnot, all these server-side technologies have been around for a while. They're very mature. They provided dynamic content, but there was a need for some client-side dynamic content, right? For instance, one of the initial things that we want to do is maybe give some initial feedback to the user, immediate feedback. For instance, if I was filling out a form, right? I would like the browser to tell me right away whether my form information is valid or not, right? I don't want to have to waste sending bad data to the server using its resources, then coming back telling me that the information that I posted was bad, right? It's just a bad use of resources. Yes. What if we could distribute some of that logic across all the different little PCs, all the ones who are accessing that information, and we could give immediate feedback right there and then, right? Maybe highlight and tell them that they're missing something, or we're asking for numerical data and they're typing characters, right? Alphanumeric. We would like to give them feedback right away, right? So they came up with that additional technology, JavaScript, that allowed you to create code that ran on the browser. It was downloaded from the domain, right, from the server, but it was executed on the client, on the browser. And that content, that JavaScript, could interact with the browser and give immediate feedback to the user, right? It improved user interaction. It reduced any misuse of network resources, right? And it was very, very successful. Now JavaScript has grown more than just that. It's been it on its own. It has also become its own framework. It has also matured in parallel with server-side technologies, and today is becoming the leading mechanism by which we build websites today. Okay, JavaScript is kind of like it's taking over the world. JavaScript on the client, JavaScript on the server, and JavaScript on the database. Right, JavaScript everywhere. It's kind of like Java wanted to do, right? Java wanted to run on the server, or wanted to run in the database, and kind of like abstract the entire framework, right? But I think JavaScript was able to go a little further. All right, so anyway, this was great for quite a while. Now, folks, as these matured, as we had the .com bust at the turn of the century. There was a lot of great innovations that occurred at the end of the last century, where if you had a .com, people were investing in you, they were throwing money at you, and a lot of great innovation came out of that. Even though a lot of all that money just disappeared, but a lot of great things were invented back then, and the basic takeaway is that, hey, maybe our financial and our business models were wrong, right? We were applying it wrong, but the technology is still good, right? Let's see what we learn from it, and let's see how we apply it in a responsible way, right? And we started reapplying a lot of those great inventions at the turn of the century, and today we see that there's been an explosion in the amount of data that we create, the amount of information that we consume online, the amount of information that we generate. We just grab a phone and just wave it, and we're generating this huge amount of streams of information that somebody is tagging, somebody's analyzing, storing somewhere in a database, right? Trying to sell us something. So people were asking themselves, and after using a lot of their personal computer programs, saying, well, why do applications on the web, why aren't they as snappy? Why aren't they as responsive, right? Or as the applications that I have that are running on my desktop, and more and more you see a lot of frameworks trying to fulfill that gap, right? Or to fill that gap, to make applications on the web feel as if they were desktop applications, right? To have the same kind of feel, the same kind of an interactivity, right? That you can drag things around, you can move things around, that it responds immediately to you, right? As opposed to having these clunky applications that you click, the server thinks a little bit, right, and then comes back and re-renders the entire page, right? So a lot of effort has gone to beef up this side of this of the stack, okay, and a lot of it. Google has spent a lot of efforts in doing those kinds of things, right? Creating tons and tons of infrastructure for implementing those things, right? And we see a lot of applications that they have, right? Google Sheets and Google Docs and their email applications, and all these are all right client-side applications, right? Backed by a server, obviously for the data. Right, but they're very responsive. They're kind of the gold standard on single-page applications, right? And they created tons and tons of infrastructure to allow us to build those things, right? One of them is AngularJS, right? AngularJS. And AngularJS is the A in mean. Okay, and that's where this comes from, right? In an effort to beef up the server-side framework that allows us to create more interactive, more client-side applications, right? And a lot of the same ideas that were invented here on the server side, like inversion of control, model view controller, all the design patterns that were designed or were created here, they're making their way into client-side libraries, right, and making it the standard way of implementation, right? So Angular is just one of several model view controller JavaScript libraries. Okay, there's quite a few out there. Ember, Meteor, there's tons. Sail. There's tons of them out there, right? React. A lot of these are model view controller libraries that, again, they try to abstract or create abstraction layers, just like these guys did. Right? And we'll see a lot of the ideas that were invented here are being ported over to the client side. Okay? All right, so because there was a lot of effort at creating client-side applications, right, on the browser that would run on the browser, the data that was being consumed by these applications were JavaScript friendly, right? They were JSON, right? JSON. I guess I could make this a little bigger, can I? Okay, so we have here on the browser, we have here on the server and have the database. Okay. Yeah, so we have applications running on the browser written in JavaScript. So they are consuming data that they want to consume it in their format, right? They're expecting their data to be JSON friendly, right? So JavaScript object notation. So they're generating a stream of JSON, and presumably they would like to consume it also in the same format. Okay. Notice that the application running in a browser it has a lot of limitations, right? It doesn't have a database, no database. It doesn't have access to the file system, no access to the file system. It doesn't have unrestricted access to the network if it wants to go out and go to the cloud, right? This was a no-no a while back, right? Cross-domain was not allowed. Okay, so it's very limited. It relies on something running on the server that provides the data, right? So on the server, whatever infrastructure you choose, you had to be able to consume JavaScript, and you were supposed to be able to generate JavaScript back to the browser. Okay, and there's lots and lots of frameworks that allow you to do that. Certainly, ASP and JSPs and PHP, they all have mechanisms that allow you to easily generate JavaScript JSON data back and forth. Okay. But it was cumbersome, right? Because if you had Java, well, Java had its own little data model, right? Its own data model running on the server. You needed to do the conversion, right, between some data model represented on the browser and then some data model that was represented on the server, right? And you had to do the mapping, right? Usually there would be libraries that do the conversion automatically, right, automagically. And that would create the data instances in Java that would allow you to then run your server. Okay, and then on the server, when you wanted to store, typically this was SQL. Right? There was another layer of conversion between the object model, the object-oriented data model in the server, that then had to be converted into some flat, set of tables, right, that had relationships amongst them. Right? So there was 3 layers of conversion. Right? JavaScript to Java to SQL, right? And there's lots and lots of libraries that allow you to automatically do this conversion, but it's kind of a nuisance, right? That you have to go back between all these 3 different ways of interpreting the same data model, right? So there was a lot of effort on simplifying this part of the server, and obviously a lot of the various frameworks provided lots of different ways that you could do this, but there's always the question of impedance, right? That certain data models that are particular to one framework don't necessarily have a one-to-one mapping to another data representation, right? In particular, for instance, you can have inheritance here, you can have overriding, you have tons of data modeling here that is just lost when you convert it into a SQL representation, right? It doesn't necessarily map directly, so there's a lot of missed opportunities there. Same thing between this conversion, right? So there was some effort at replacing this with servers that were natively JavaScript friendly. Okay, which one of the more common ones out there, not the only one, but one of the first ones was Node.js. So Node.js is the only thing Node.js is an interpreter that allows you to execute JavaScript on the server. Right? Typically, when you think about JavaScript, you think, oh, it's code that executes on a browser. But we can execute JavaScript also on the server. Right? Node.js is just an interpreter. Just like if you say Java or Python or whatever, and you give it an executable, a Java executable or binary, Node.js has an executable that if you give it a JavaScript file, it runs on the desktop. Now, running on the desktop is quite different from running on a browser. On a browser, you have Windows, right? You have the document object model. You have CSS. You have HTML. There's none of that here, right? You're running on a server. There's no Windows, right? There's no alert boxes, right? There's no keyboard, right? There's no mouse. There's nothing of that, right? You're not interacting with a human being. Typically, you're interacting with server-side resources like a database or some network connection from the outside. So Node.js allows us to create a JavaScript server-side middle tier that can intercept HTTP requests from the browser, parse those JavaScript objects into JavaScript objects. There's no transformation layer here, right? It's direct, and it's JavaScript to JavaScript, and you can run your business logic in native JavaScript. Just like there's been an effort to beef up the client-side framework like Angular and React and all these abstractions. There's the same thing on Node.js. It's been a lot of effort to beef up, server-side JavaScript coding. Okay, and in particular, Express. Express is one of the libraries that we're going to be using throughout the semester. That's going to allow us to very, very easily create web services that allow us to expose a data model, expose a data service, make it available out there to anybody who wants it, right? Like Netflix does, right? Here's Netflix, or IMDb, right? Or Yelp, or any of these cloud services that allow us, to just connect to them and query, right? And ask information. What are the popular movies out there, right? What restaurants are around me? What events are happening today in Boston? Yes, there's a lot of these services out there that you can just make a request, an HTTP request, and it comes back with an array of objects, right? That we can then manipulate. So we can do the same thing. We can expose our own data model from our own little application and expose it to the world. In particular, expose it to our applications, right? Expose it to our applications that can retrieve the data and then render it on the client side. Notice that the A, the N, and the E, right, are the E, the A, and the N in mean. Okay, so Express, Angular, and Node.js, right? The last piece of the puzzle is the M in mean, right? And it takes care of this last layer over here, this data layer, okay, where the persistence, instead of using relational databases, we're exploring other ways to persist data, right? Typically, we would like to, in particular, would like to persist it in such a way that is friendly to the data representation that is going to be ultimately used out here, right? Obviously, this not necessarily has to be a one-to-one mapping. This typically has a fairly hierarchical, fairly normalized data model, whereas in the front end typically is denormalized, right? It's fairly flat, right? So there is some conversion, but that conversion is because of the business, right? It's a business decision on how to do that mapping or that representation. But so today we're not going to be using SQL. We're going to instead of using NoSQL. So NoSQL databases, right? What would databases look like today if we would have to reinvent them, right? Trying to solve problems from today's applications, right? So NoSQL is an umbrella term for a family of databases out there that just don't use the relational mechanisms of representing data, right? So we're going to be using MongoDB, and basically what MongoDB allows us to do is grab a JSON object, right? That might be instantiated in memory. It allows us to serialize it to a database, right? So it's not really it's an object database, right? We're storing objects, right, and we're retrieving objects back into memory, back and forth. So there's quite a few things that are a little bit different on how you work with it, and we're going to spend some time going over that part. So in particular, it can store JSON data, right? You can store JSON data directly to a database, and you can retrieve JSON and just send it back to the client. So it's JavaScript and JSON on the client, JavaScript and JSON on the server, and JSON on the database. Yes? Everybody okay? And it all started because of this, right? Google and Netflix and all these folks that were moving everything to the cloud, right, creating these applications that were accessed through the browser, demanded servers that were friendly with JavaScript, and then demanded data that was also friendly with the end result. Make sense? All right. Yes. Question.
Yeah. For this particular course, is there a reason why you chose the mean stack over like other stacks like Lean and Lamp and stuff like that?
Well, Lamp would be again would be server side, right? Would be PHP, right? Would be, so that would be server side. Okay. Yeah. Again here. It's a very common architecture out there in the industry, right? Is not to use necessarily Node.js, right? But use Java here, right? So Angular, right? Whatever you have here, it doesn't really care what you have on the serving the JSON, right? As long as it can generate JSON or consume JSON, Angular or React or any of these MVC, they don't really care, right? And here we could have stuck with a relational database, right? Like MySQL in a LAMP stack, but again, this is a very popular single page application stack, right? So this is what we're going to be focusing on this semester. Single page application, meaning you hit one HTML file and you don't hit any other HTML file ever again, right? It's the same file, right? The way it works is that you ask for index. So here's index.html. It's downloaded to the browser. Let me just give you the life cycle of a single page application. So here's the browser. Here's the server. And here's the database. Okay. So the browser, you navigate to that one single page index, right? And to the server comes back. Here's the browser has your index page. The index page has references to other things, right? Has references to other JavaScript files here. Lots of CSS. So here you also have CSS. You also have a lot of JavaScript here. So that index file goes back to the server and says, hey, give me those other files. And the server responds with those CSS files and those JavaScript files. One particular JavaScript file will be the entry point to our Angular application. Okay? And it's going to take over the entire page. It says, ooh, this is my page. I'm going to do with it what I want. Okay? In particular, what it's going to do is that it's going to be start asking the server for data. Okay, I am Facebook. I need to know the activity of this person who's logged in. Right, so they'll make a query to the server, and maybe it'll say /API/activity. And the server says, oh, okay, I know how to respond to that. Let me make a database query for all the activity for the currently logged in user. This returns a JSON array, and this API returns a JSON array back to the browser. The JavaScript portion iterates over the array. As it's iterating over the array, it makes entries, dynamic entries into the DOM, okay, the document object model, right? It creates the HTML on the fly, rendering as it goes. Okay. If I want to create a new post, I need to navigate. But I just said we don't navigate, okay? I need to navigate to a different page because I need to create a new post, right? But we never leave the index page. So we fake it. What we do is that if you want to post, we replace the DOM. We go fetch for another HTML file. Without HTML file, we call them templates, or we call them snippets of HTML or partials. So there might be a post.html. So there'll be an AJAX call, right, on the server, back to the server asking for this post. It comes back without refreshing the page. We cache the page on the client, cache the page on the page, and we dynamically render the post so that you can do your new post. When you say OK, right, we replace the DOM and put back the previous page there dynamically on the client. Okay? we never actually go fetch any HTML pieces or portions that we fetched already. We didn't go fetch them again, right? We all cache that on the client side, right? Unlike LAMP stack, right? We would always go fetch a brand new version of the page, right? There's no caching. Well, although you can do some caching on the server side too. That makes sense a little bit, right? So yeah, so we never leave the index page. What we do is that our index page is actually going to be very, very simple. It's just going to have a single div, a single div. That's all our index page is going to have. No content whatsoever. If you look at some of the single page applications today from Google or Facebook or any of them, you look at the index pages, there's nothing in it. It's an empty HTML document. It says, where's everything? Where's my post? Where's all my content? It's because JavaScript programmatically injects the content, right, into that div, right, to give you the feeling or the functionality of navigating from one page to the next, right? It brings out the DOM portion, it injects a new one, brings it down, and then injects another one, right? And this happens seamlessly, and you don't realize it. Same thing when you flick a Google Maps, right? You see all these maps, right, animated. They're not all there, right? The client has to go back to the server, fetching all those images and filling all those blanks real quick, right? Yes.
So if you have like a backend that it's like legacy, so it's like made. It's not like single page. Is it with Angular? Is it easy to just like insert this view with that old backend, but just like kind of rendering like the pages dynamically, or?
Right. So notice that there's two types of queries, right, that are happening from the Angular side, right? They are asking for snippets of HTML, right? That is going to be used for injecting different portions and rendering the page in snippets, right? So all these HTMLs are meant to be snippets, right? Pieces of pages, as opposed to an entire page, right? So that's one problem, right? With typically in LAMP or other server-side technologies, it's an entire page, right? They might include snippets on their own on the server side, but typically it's just one single page, right? That you navigate to the login page or the post page, and those are all self-contained, full pages. So that's one of the first problems of porting server-side technologies. The other is that typically those pages come empty. There's no data in those pages, right? So for instance, for the list of my posts, it would come back with a template on how they would render, but not the actual posts, right? Not the actual content. For that, I need to go back to the server and ask for data. Give me the data. It comes back with an array of objects, right? Which I then render. Okay, so that's a little bit different as well, right? So there's two pieces that we're going to be working on the server side. One is for fetching static content, all the HTML, snippets, CSS, JavaScript, right? All that static content, and then separately the content, the data, right? We're going to be querying our data services for our dynamic content. So this is going to be the dynamic portion, right, of the data, not the HTML. The HTML, as far as the server is concerned, all that HTML is static, right? It does not execute on the server, right? It's brought to the client side, and then on a separate call, the data is then used to dynamically render that on the client. That has a little. That has some. Well, it has its pros and it has its cons, right? Notice that if I need data, I always have to go back to the server, right? The server is our source of truth, right? It's one single place. On the first fetch, it's kind of expensive, right? Because I just downloaded the HTML, but it's empty. It has no content. I have to do a second call to go fetch the content, the data, right? So it might look as it's double, right? But notice that the HTML that comes doesn't actually have the content. That's going to be rendered dynamically here. It's only very small snippets of HTML, right? Which is going to be dynamically added later on. But then if I'm adding one or adding a brand new one or I'm deleting one, then that's where it becomes very, very efficient, right? I'm not if I delete or update a single element, I don't need to re-render the entire page. I only delete and update that one single element. Right? That's very, very efficient. Right? As opposed to in server-side technologies, it would be a completely brand new re-rendering of the entire page, even though if I update one single little snippet. Right? So in the long run, it can be very efficient. Yes?
So when you do update data client side, you are sending a request back to the server if that needs to be changed on the server. Like
Yes.
a Facebook post, if you delete it,
Yep.
it should be okay.
Yeah, not until the server says that it's been deleted,
Yeah.
has actually been deleted.
Yeah.
Right? And typically all these calls are asynchronous, right? The client says, "Oh, you're removing a post," right? That is the first thing that happens is that there's a call to the server that says, "Hey, they want to remove this post," and the server then goes to the database, right? Removes it from the post. The server waits for the database to come back, and when the server says, "Oh," the database says, "Yes, they've removed it," and then asynchronous comes back to the client saying, "Yes, I have removed that." Then the client says, "Oh, okay, finally I can remove it from the DOM because I want to render always things that are true, right? I don't want to render something that is not true." Yes?
So the speed benefit doesn't come from the fact that it acts without the server. It comes from the fact that it can just remove part of the DOM client
Yes,
side.
exactly.
Okay.
Exactly. Yep.
Is there some framework that allows you to act like without the server's like acknowledgement that the command is succeeded?
Yes. I mean, no, but that's by design, right? So by design, we wait here, right? So yours would be an optimistic delete,
Yeah,
right?
that's why.
You optimistically hope that this is going to happen, and you don't wait for
Yeah.
acknowledgement. You could certainly code it that way,
Until you
Right.
refresh and then it's back
Yeah.
again.
right? So actually, the first assignment will be to do it that way.
Okay.
Okay, and then as we progress, we're going to be introducing asynchronous communication, right? For these to wait on each other, right? For acknowledgement from the server, right? Yes.
My question about the database is a little off topic, but if you want us to use an API from another website, right?
Yes.
To get the data.
Yep.
So would we cache a copy of the data, or would we build the main objects on top of that data, and we would just reach to that API for the data?
Yeah. Very, very important. I was going to cover that in the project, but let's talk about it. So yeah, for the project, I guess it's a good segue to the project. And so you're going to be required to choose some cloud API, okay, for whatever domain topic you choose, right? Say it's I don't know, Yelp, and so there'll be a homepage, right? There'll be a place where you can search, right? Typically, maybe some input field. So maybe this is IMDb, right? And you search for Alien Covenant, or it come back with a result set of all the Alien movies, and then you would render that dynamically over here. So this was an asynchronous call to an IMDb API, right? That comes back with an array, right? Up to this point, your database has nothing to do here, right? There's no need for you to cache any of this information, right? It's only for read only, right? And then you would show maybe a summary of your result set. If you click on one of these, then you would perhaps want to go to a details page, right? That shows details about that one particular movie, right? You would pass that maybe as the ID of the movie to this page, and this page would then go back to the IMDb API saying, "Give me more information about this one particular movie," right? And then this would come back with a single object as opposed to an array of objects that has much more information. Might give you lots of poster images. It might give you the cast, maybe the plot, okay, and all sorts of information. Maybe it'll give you some reviews of folks who have reviewed this online. Again, no database access. There's no database, no local database of yours has been used at all yet. Yes? Okay. And notice that I haven't had to log in yet. Right? So anybody should be able to use this, right, without having to log in. Not until you ask me to do something that's specific to you, right? Would I then need to have a local database, right? That I need to remember something about you, right? So for instance, you say that you like this movie, right? And you want to favor it, right? So if you favor it, then now I need to know who you are, right? And I need to write somewhere that this particular person likes that particular movie, right? So So you might have chosen a data model where you might have a user data model, you might have a movie representation, and you might have a likes, where you have all these users in your data model and all these movies, right? And you create a relationship between one user liking that particular movie, right? So you have to make those entries, yes? Now for the movie, what do you have to make that entry. You have to say, well, who are you? And this is the movie, and I have to remember that you like it, right? Now that movie might already be in the database, it might not be in the database, right? In your database, right? And you would only enter movies in the database that you need to remember, right? Only the ones that you need to remember, right? Out of the thousands of movies, it might be just one user, one movie. It'll be just one entry and one entry. I don't need to remember all the movies unless somebody actually wants to interact with it. That make sense?
Yeah.
Okay. Now, in the movies, what do I store in the movie? So typically, we would store a minimum of what we need. Okay. Depending on what it is that we want to cache, or how willing are we to store the minimum information that we might want. Typically, we want to be able to remember maybe the title of the movie, maybe, okay? Maybe a thumbnail of the image, okay? Enough so that in your profile, right, just me, and I want to remember all my favorite movies, and I want to list those movies. I want to list all those movies. So I need to perhaps know the thumbnail of that movie and maybe the title. That should be enough, okay? In a long list of things. So those kinds of information I might store in the movie, right? There'll be where I have the title, string, the poster image, right? Maybe another string, okay? And also the IMDb ID, the ID of the, how IMDb uniquely identifies that resource, right? And probably a unique identifier, some primary key locally to your database, right? And this should be enough for you to dynamically render your list. Yes? Okay, there's no need to encode other things here, like the plot and the cast and reviews and things like that, right? There's no need for that. I can always fetch it later when I need it. Right? So for instance, one of the requirements is that if I do click on this should take me back to the details page, right? The details page, I can re-render it with this ID, the IMDb, right? I can always go back and fetch it from the IMDb and re-render the entire page. Yes? No need for me to cache the entire thing. Again, it depends how responsive you want to be, if you want to cache more things, right? So that you can provide an immediate response, right, without having to go fetch it in the cloud. That's up to you. Okay? But there should be a minimum. Some people would say, well, why do I even need the title and the poster? I only need the IMDb ID because I can fetch the other two as well. Yes? Right, you can make the same argument, right? I only need the IMDb. So, but for rendering this means that for each query here, you have to go fetch it from the cloud. Right, that's very expensive, right? Iterate over all my movies and go fetch all so that's very expensive. So, cache something locally so that you improve some of those queries. Make sense? Also, it might some of your projects might require that you do a mesh of data, right? Of which some of the data you fetch from the cloud, right? And some other data, okay, you fetch from local storage, right? From your own local database, right? So, for instance, it might be that users review movies, right? So one user creates several reviews of a particular movie. Yes, right? And those are stored in your database, right? So these reviews that are shown down below are reviews for that particular movie by certain users, right? Or one movie was reviewed by many users, right? So they're kind of like a many-to-many relationship. So here you have all the users, user 1, user 2, user 3, right? So this bottom half is rendered from your local database, and this top half is rendered from a remote remote server. Make sense? Right? And you kind of like have a mesh of your data. Make sense? Okay. And this is very, very easy. It is very easy to do. Okay, so I'll show you. Any questions that make sense? All right. Let's go. It's almost 3. Okay, let me stop this.